Aloha, Richard Halverson here. This is ITS148, and today I'm going to do uh, hashing, the second hashing chapter. So let me share my screen. Except I'm not going to do this. No, let me go here. All right, so let's go to the textbook. Oh no, there's only one. Oh yeah, no, I'm going to do the first hashing. I'm going to start with chapter 26 hashing tables, hash tables. All right, so let's and there are challenges, there are challenge activities in every section. Okay, so hashing is another data structure. This is the second semester programming class, and in this class we learn primarily all the basic data structures that we use in computer science for all the different ways of storing data inside the RAM memory of the computer that your program has access to in a random access fashion. So a hash table is a data. Okay, so with a hash table, you come up with some function that'll map a key directly into an address. Okay, so and normally random access memory or normally accessing any variable is that way. You just, if you want to access a variable, it doesn't matter what variable it is. The amount of time that it takes for the processor to access the variable and modify it and store it back, to do an assignment statement is the same no matter what the variable is. Well, a hash table tries to emulate the same sort of functionality, except for with memory that is way larger than the actual memory space that we have, and you'll see what I mean by that. Okay, so it's an unordered. It stores unordered items by mapping each item into a location. Let's see, is this important? Let's see, I'll get to explaining this. Okay, a hash table. In a hash table, an item's key is the value used to map to an index. Okay, so one way you can think of it is if you have an array and the key is the index to the array, and so with an array, just it doesn't matter what the index is. You can the amount of time that it takes to access any array element is the same no matter what the index is. Okay, that's how a regular array is supposed to work. Well, if the array is a million times bigger than the amount of memory that you have, let's see, maybe not a million, maybe 1,000 times bigger than the amount of memory that you actually have in your computer, well, you can't really use an array because the index can be, the amount of memory is, there's not enough memory for all the indexes. Well, a hash table sort of solves that problem by doing this mapping. And the idea is that you want the hash function to work most of the time. I mean, almost all the time. And every now and then it doesn't work, and then so you have to swap out a bunch of memory and swap in memory, and that kind of thing takes longer. Or you have to do like where you have these misses, and then if you don't find the item that you want in the first hit, then there's an algorithm for looking at the second place and the third place and so on. So each hash table array element is called a bucket, and a hash function computes a bucket index from the item's key. So let's just go through this and see what this looks like. So we're going to create a new hash table called player nums, and it's got 10 slots to it, and then we're going to insert a bunch of players. Okay, and we only have 10 slots, but we're going to insert all these players, and look, these player numbers are kind of all over the place. Here we've got, okay, so here we've inserted, and the hash function is, it's where we just take the key value and we take it mod 10, and then that's the value that we use for the key. So 116 mod 10 is 6, so this one gets stored in 6, and then the next one is 12 mod 10, which is 2, so it's going to get stored up in 2. And the next one is 23, so 23 mod 10 is 3, so that's going to get stored in 3. And then when we want to search for 23, we take the 23 and we take mod 10 and we converts to 3, and then we know that that this is the one. So that one works. Okay, in this particular example, every single one of these mapped to a unique spot over here. But what happens if they didn't map to a unique spot? Well, I bet you that's the next example here. Normally, each item is stored as an object with several fields, such as a person, object, with an ID number uses the key. For simplicity, this section represents an item just as the item's key. Okay, so we're just saying for simplicity, we're just using the item's key here, but actually there's probably another record that's associated with it that's got a bunch of other stuff in it. Okay, so we see this is the record, and when we do the hashing function, it just looks like that. Modulo, this is a common hashing function operator. Hash table search efficiency. How many buckets are checked for a hash search for 45? Well, I think it's just 1. Yeah, so yeah, right. Okay, so here we're going to talk about collisions. Okay, so collisions is what is okay. So here, so if we were to actually have a memory that could store all of these players, and let's say the players run from 0 to 200, or from 1 to 200, and so these are the different numbers of the players, but we only have and so to do this without hashing, where this would work, where the access would be the same every time, we would have to have 200 slots. Well, let's say that 200 slots is not practical, but 10 slots is practical because we're only going to have 5 players total, let's say. Then we could have some sort of hash function, and where somehow the player number will map into a unique spot. So the problem comes when two different things, the keys map to the same spot. So let's say we've inserted player number 116. Let's say we wanted, after this, insert player number 56. Well, 56 mod 10 is 6. So that would map into here. Well, there's already something there. So what do we do? Well, that's where this collision algorithm comes in. And there's a bunch of different collision algorithms. And one is just to go to the next empty spot. One is, another one is you don't go to the first empty slot. You have some sort of a random number where it's some random number farther down, because by making it random, then there's less of a chance of a second collision. And then there's chaining, where you would actually have a second little record here that connects to this first one. And so a searching involves first mapping to the right slot, and then if there's a linked list here of more, then you have to traverse down the list to find the right one. Anyway, so that's what we're going to talk about now, is chaining. What time is it now? All right, so let's let's do this one first. Okay, Hash table of non-negative integers has modulo hash. Okay, it's got mod 20. All right, so it's a hash table with non-negative integers has a modulo hash function of key mod 20. Hash function index range is 0 to 19. Is that what this is asking for? Okay, so the hash function index range is, I think that's what they're asking here. So item 170 would go to 0. Let's see if this is right. Oh, no, no. Okay, so no, it's wrong. Why? Because 170 mod 20 is 10, not 0. So it'll give me another chance. All right, so mod 15. Hash function has a range of 0 to 14. And 136 will go to bucket, well, I'm going to calculator here. Can I pull up a calculator? Let's see. 136 divided by 15. Oh, does 130, does 15 goes into 130, doesn't it? So it's, I'm sure 15, no, does anybody know what 136 divided by 15, 136 divided by 15 equals 9.066. Okay, so then I subtract 9. And I got 0.066666, and then I have to multiply that by 15 again to get back what the, oh, it's 1. Okay, it looks like 135 divides into 15 evenly. So the answer is 1. All right. Why? Because 136 mod 15 is equal to 1. Okay, let's do the next one. Okay, an ordinary array contains items with keys. With these keys, a hash table has 15 buckets with a hash table function of mod 15. The hash table contains the same items as the array. Okay, so item 0, I guess I'm supposed to say item 0 is 13, I guess. Is that what this is saying? I think so. Item 0 is 13, and the hash table would be, what's 13 mod 15? It's 13. How many elements are checked? Oh, wait a minute. This is a different question. How many elements are checked when searching for each of the following items? I don't quite understand the question. Okay, 22 mod 50, oh, this is a different problem here. Item 22. Zero, 1, 2, 3, 4, 5. Stephen, you've done this one, haven't you? You're muted.
Yeah, honestly, I did it like a month ago. So
a month ago, okay. Okay. All right. So item, I don't, okay, okay, this must be, there's no 0 in here. Because item 22 is in here. Here, tell you what, I'm going to put this over here. So this is the same problem. Oh, and this is the solution. Okay, so so for this problem, item 22, this is supposed to be 6, and this is supposed to be, this is how many elements are checked when searching for the following items. Okay, 1 check, 2 check, 3 check, 4 check, 5 check, 6 check. Okay, so I think what we're comparing it to is a linear search. I think we're comparing it to a linear search through an array. So because we're looking for item 22, we have to first look at 1, 2, 3, 4, 5, 6, and that's how many elements are checked when searching for this one. So there, but for a hash table, it's just it's just 22 mod, 22 mod 20 is 2, and it's just 1. It's always it's going to be 1 unless there's a collision. All right, for 17, it's going to be 6 because it has to go all the way to the end and it never finds it. And in this case, again, it's just 1. And for 5, it has to go, oh, it's 4. 0, 1, 2, 3, 4. So it has to check for 4 items before it finds it. And a hash table is just going to be 1. All right, so that's this answer. So let's go to this answer. When we're searching for 0, we have to go through every one of them. And before we know that the 0 is not in there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it goes through 9 items, checks 9 things, and the hash table will just check 1. It's just the answer to every one of them. And 11 mod 15 is 11. So this is going to be 1 again. I don't think it matters. But 1, 2, oh, there's no, okay, 11 is there, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the last one, looking for 21 mod 15 is going to be like 6. But it doesn't matter. That's just 1, checks for 1 thing. This is going to be 1, 2, 3. So that's my answer. I see. Okay, so 0, to determine that 0 is not in the array, every element of the array must be checked. Okay, so let's just see what the next one is. An empty hash table called hash table has 10 buckets and a hash function of key mod 10. The following operations are performed in order. Select which operations cause a collision. Okay, so this is going to put it into a bucket number 3. This is going to put it into bucket number 6. This is going to try to put it in bucket number 3, but bucket 3 already has something in it, so that's going to be a collision. This is going to try to put it in bucket 9, no problem. This is going to try to put it in bucket 3, in bucket 6, but there already is something in bucket 6, so this will cause a collision. All right. So there we go. Let's go to the next one. Okay, so chaining. This is kind of an easy way to take care of collisions if you have linked lists, if you're handy with linked lists, because what you do is you just each element in the hash table can link to another record, hash table record. And so that's what this algorithm describes. So if we let's just go through this. 77. This is it's gonna it's 10. So this is gonna put 77. Oh, I see. So so each element is actually a pointer to a linked list. So the first time it put in 77, it creates this linked list with the 77 there. The next time it does 8, and so it creates a linked list and puts the 8 there. And the next time it's got another 7. This is going to map into 7 again. And so then it's going to go and put the 7. It's going to put 17 on, it's going to link it onto to the end of the linked list that's at 7. And the next one is going to do searching for 17. It's first going to map to 7, and then it's going to go down the list until it tries to find 17. And if it finds 17, it returns it. Otherwise, it's going to say it couldn't find it. So this talks about inserting something into the hash table and removing something from the hash table and searching the hash table. So this is an example of a hash table that's got items inserted and so on. So you can go through those exercises. How many list items are compared when we're searching for 62? Well, it's just 1, I think. Yes, 1. All right, let's do this. Hash table, this is showing the hash table function is mod 5. Assume items are inserted at the end of the list. Okay, great. So let's start this up. And the first thing we're supposed to do looks like this after the 89 and 41. Select the bucket containing the following items. Oh, okay. So this is mod 5. So 41. Well, what am I supposed to do here? Say which bucket select the bucket containing the following items. Oh, wait a minute. Okay, so it looks like this. Then we do this. We add an 89 and we add a 41. The 89 is going to be what's 89 mod 5? 4. No. Yes, 4. 89 mod 5 is 4. So 89 is going to go hooked onto this one. And 41 mod 5 is 1. So 41 is going to get hooked onto this one. So select the bucket containing the following items. 41, that's going to be bucket number 1. 89 is going to be bucket number 4, I think. And 54 is going to be bucket number 4. Just right? Yeah, okay. Let's do number 3. Hash table has this. The hash function is that. The hash function is that key mod 5. So we got something that looks like this. And then we're going to remove 30. Remove 30. And we're going to remove 15. So we're going to, there's no 10, 25, 30, 35. There's no 15. So I guess nothing happens then. What is bucket 0's list? Bucket 0? It's going to have 10, 25, and 35. That's what I think. All right, let's do number 5. The hash table looks like this. The key, the function is mod 5. The maximum number of comparisons required to search for a key. Right now, the maximum number of comparisons would be, if it were, let's say we're searching for 52, that'd be the maximum. Because it mapped to 2, and then is it this one? No, this one, no, this one, no, this one. That's the most. So the maximum number of comparisons required to search for a key would be 4. minimum number of comparisons required to search for a key. I guess 0, because it would map to, let's say we're looking for 51, it maps to 1, and then there's nothing there, so we know it's not there. That's what I'm going to say. Yes. All right, linear probing. Okay, so you know, chaining is conceptually simple, but you can chaining requires, you know, linked lists and all that, and sometimes you just want to, you know, you have a huge hash table. The hash table itself is very large compared to how many items are expected to be inserted into the hash table. So we still have we have a hash table that still has way more spaces than we need, but still the key values can be huge. So we still want to use hashing. In cases like that, we can just search and find a nearby bucket that's empty. And so linear probing just simply, if it maps to a bucket, if a key maps to a bucket and there's something there, then it just goes to the next one. If something there, it goes to the next one. Something there, it goes to the next one, until finally it finds a blank one. It finds an empty one. So here, for example, let's just try this one. So we're going to insert 124. So that goes into 4. Well, 4, there's a collision. So what we're going to do is we're just going to see if the next one's empty. It is empty, so we just put it there. And then we're going to search for 124, and we look for 4. We look at 4, it's not there. So then we look at the next one right after it, and we find it's there. Very good. And now we're going to search for 33, and we go to 3 and look. 113's not there. So then it's going to look at the next one because there's something there. It's not there. And then it's going to look at the next one because there's something there and it's not there. And then it's going to look at the next one and there's nothing there and it's not 33. So now we can conclude that that the 33 is not in there. So you can see this can be humbug when there's collisions, but you know, at least you don't have to have linked lists or anything else like that. And as long as your algorithms for inserting and finding are correct, then you know it's just going to cause a little bit more time for some collisions, but hopefully if the hash table is large enough, most of the time you won't even have a collision, and it'll just take one operation. So let's I think we know. Okay, so then we have this thing where we have to mark. Okay, so when we start removing items now, we have to mark if okay, so once we start removing items, then there's going to be blanks. There's going to be empty ones. Like let's take this one back here. Let's say that you know, someone searched. Let's see. Well, actually, this is a bad example. Okay, yeah. Let's say that something that maps to 30. Okay, so let's do 30. Let's say we're searching for 30. Okay, let's say before we search for 34, or no, before we search for 33, let's search for and remove 34. Okay, so if we're gonna search for and remove 34, then it's gonna map directly to here. And then if we remove it, then there's gonna be an empty spot there. There's gonna be an empty spot there. Then when we search for 33, no. Let's say after we remove this, let's say then we search for 124. Let's say after we remove 34, after we remove 34. Then we come back and we want to search for 124. Well, 124 will map to bucket number 4. It'll go to bucket number 4, and bucket number 4 will be empty. So then is it going to conclude that there is no 124? Because no, we have to, when we remove the 34, we have to mark this bucket here as it's either empty from the book. It's either empty since start or empty after removal. Okay, so what happens is when the hash table is empty, all the empty buckets are marked empty since start. But if along the way something gets inserted into the bucket and then it gets taken back out again, then it gets marked as empty after removal. So if we are up here and we have inserted 124 right here because this one had something in it, and then we remove the 34, then bucket number 4 is going to be empty, but it's going to be marked as empty after removal. So that means that later on, when we come and search for 124, it'll map to 4, and 4 will be empty, but it'll be empty after removal, which means, well, 124 could still be here. So you go down to the next one, and lo and behold, there it is. So that's how you handle. So that's this thing about empty before removal, empty since empty since start and empty after removal. So let's do one of these, okay? All right, I'm just going to start it. And what are we supposed to do? Oh, here we go. Okay, so it looks like this. Okay, and it's mod 10. We're going to insert 30. So 30 is going to get inserted into number 2, right? Because it's going to map to 0. 0's got something in it. What's the next one? 1's got something in it. What's the next one? 2's empty. So this is going to get mapped to 2. Okay, then we're going to try to insert 43. Well, 43 is going to map to this one. There's something in there. So it looks to the next one, and that's 4. 4 is empty. So this one's going to map to 4. And then this one we're going to try to insert 76, and 76 is going to map to this bucket, and it's empty, so it can just go right into that bucket. Okay, so that's the answer there. All right, let's just do the next one here. We're going to insert 15. So 15 maps to 5, and so there's something there. There's something there. So it goes into 7, because 7 is the first empty one. And then we're going to insert 39, and 39 maps to here, something in there. Goes to the next one, something in there. Goes to the next one, something in there. And then so 2 is the next open one. You see how it wraps around? Mod 10 wraps around. All right, okay, so let's see if that's correct. Okay, let's just go quick do the last one here. Okay, so here we've got empty after removal. So that means that if we're searching for something and if we're searching for something, and then just because there's nothing there, that doesn't mean it wasn't, added later on. So you just have to act as though something is there if you're searching for something. All right, so the operation hash table 76 is removed. What specific sequence of buckets probed by searching? Okay, the hash table is this, uses linear. I'll tell you what, I'm going to do number 3 instead. Okay, so hash table vals uses linear program. Okay, insert 10. Okay, so 10 would go right into right here. 10 would go into 0. And then we're going to insert 64. And 64 is it would map into 4. 4 is 4 is got something in it. So we go to the next one. 5 is empty. It doesn't matter that it was empty after removal. Empty after removal. So let's just put it in 5. I think. Let's see if this is right. Yes. Okay. All right. Now let's do this last one here. Okay. So the operation for the operation is performed. Okay. So 72 has been added. What is the specific sequence of buckets probed by hash when now we're searching for 72? I don't. I think I don't understand the question, so I'm just going to put 2. Okay, what specific sequence of buckets probed by hash search 39? Okay, so first it's going to look at 9, and then it's going to look at 0, and it's going to see that it's empty, but it's empty after removal, so that means 39 could still be after this one. So then it's going to search and look at 1, and that's where it'll find it, I think. So let's see if this is correct. All right. Each incorrect answer is highlighted. Oh, this answer is wrong. Okay, 72. What specific sequence of buckets probed by hash 72? And we just answered. And what is it supposed to be? Wonder why 3?
If they're deleting it before they search for it.
What is that?
We're deleting the 72 before searching for it, so that's why it searches the empty one too. Right?
Okay, right, yeah, okay, that's just been executed. Oh, okay, all right, I misread this. Yes, you're right. So it looks like this, and then 72 is removed, and so it's going to be, gray. And then when we go look for 72 again after that, it's going to look at 70. It's going to look at 2, and it's going to see that 2 is empty after removal, and that means it could still be there. So it's going to go down to 3, and it's not going to find. It's going to be 3 is going to be empty, so it'll. So the answer is 2 and 3. All right, so let's do this again. Okay, yeah, I misread that. Okay, so it looks like this, and then we remove the 40. So this is going to be empty after removal. It's going to be gray. What is the specific sequence of buckets when it wants to look for 40 again? Well, it's going to, okay, so it's going to look at 0 and then 1. This is too easy now. And then what is specific sequence of buckets if probed by searching for 36? 6, 7, 8, I guess. All right. Okay, quadratic probing. Okay, now instead of just going to the next one, it's going to go to it's going to have a fancy formula to decide what the next one is. And this fancy formula is gonna depend on how many times it's actually had to compute a new possible bucket key value, or a new possible bucket. So let's see. Let's just see what this does here. Okay, the quadratic sequence is h plus. Okay, quadratic. Okay, let's just see. So it's then quadratically searches the subsequent buckets until an empty one is found. The items, if an item's mapped bucket is H, the formula is H plus starting, I repeatedly search until the empty bucket is found. So each time an empty bucket is not found, it is incremented by 1. I is incremented by 1, and then it calculates another one. So with this first one, it starts by trying to insert 55, and there's no problem because there's nothing there, so it inserts it in 55, and then it tries to insert it in 66, and it's able to do it no problem. So see, this is the bucket index. It takes the original mapped bucket, which is 6, 5 and 6, and then it adds it adds okay, so C1 is just two constant numbers, and what is, here we're using both C1 and C2 is 1, so I is 0 to start out with, so that's why it's 0 times 0 anyway. So the next one should be more interesting. What is this one? Oh, 25. Okay, so 25 is going to be 5 plus okay, so C1 and C2 are 1, so we can ignore C1 and C2, and we can just look at the I. So for this case, the first one here is I is 0, and the second one I is 0. So the key to look at, the bucket to look at is 5. 5 has got something in it already. So the next time is I is gonna be 1. So it's gonna be 5 plus 1 plus 1 squared, which is 1. So this now goes to 7. So now we're gonna look at 7 and see if that's open, and it is. So we basically skip over the first one. And then if we had to go to 2, then it would be 5 plus 2 plus 4, because 2 times 2 would be 4. So then it'd be 7 or something. So then we would jump around and come over here somewhere. So it's a way of skipping longer and longer steps. The stride, if you want to call it that, gets bigger and bigger until it finds an empty one, until it finds an empty bucket. And sometimes that can be better than the other one. So that's quadratic probing. So and then we have to do the same thing regarding the empty after removal, empty since start thing. And so this shows something. Let's go to the quadratic hashing. Let's see this. Where are we now? We are in double hashing was the last one. Okay, good. Because I have to be done in 10 minutes. Okay, so let's start with this one. This is going to be hard. Do I have to calculate this in my head? Okay, the first one is okay, so 49 is going to insert it at bucket number 9. I'm sure of it. And 20 is going to insert it at, it's going to be 1 times 1 plus 1 times 1 times 1 is just 1. So it's going to be 0 plus 1 plus 1 is 2. So I think this one's 2. And 58 is going to, it's the same thing. It's going to be, it maps in, the first one is going to map into 8. That one's got something in it. So it's going to do 8 plus 1 plus 1, which is 10 or 0. There's something in 0. So then it's going to be 8 plus 1, no, 8 plus, because I is now 2. 8 plus 2 plus 4, which is 8 plus 6, which is 14. So I think it's going to be 14. So 4. Let's see if this is right. Yes. There you go. See? So it might be a good idea just to memorize that the first time it's going to be the bucket it maps to. The second time we're going to add 2, and the next time after that we're going to add 4. No, 6. Is that right? Yeah, 6. We add the 2, and then we add the 4. And the time after that, it's going to be adding 3 and 9, which is 12. Okay, so those are things we can remember. So what's the next one? 11. Oh, it uses 11 now. Okay. What is the specific sequence of buckets probed by removing 94? Okay, so first it's going to map to 4. Okay, no. What's 94 mod? What's 94 mod 11? It's 88, 89, 90, 91, 92, and 93, 94. So that's 6. So it maps to 6. Oh, great. Okay, so the first one it's going to look at is 6. And then the one after that, it's going to be 6 plus 2 is 8. And after that, it's going to be 6 plus 6, which is 6 plus 6 is 1, 2, 3, 4, 5, 6. Oh, great. And then, am I supposed to be writing these down? Yeah, I am. 1. And then it was 12 after that, right? 3 times 3 plus 9 is 12. So it's 12 after that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, wait, no, yeah, right. That doesn't seem right. This doesn't seem like it's turning out right. That's 94. Well, I'm just gonna check it and see what's okay. So let me try this again. Okay, 3 would be 3 plus 9 is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 7. And then 4 plus 16 is 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now I'm sure this is completely wrong. So let's just see what this says. Oh, look, I was right. All right, well, you can do that. 5 minutes left. I promised I'd do double hashing. So in double hashing, it's open addressing collision resolution technique that uses two different hash functions to compute the bucket indexes. Okay, so we are either storing things into the hash table, or we are retrieving things from the hash table, and we are not using chaining, which chaining would mean that you would add more hash buckets if two different things mapped into the same mapping, same bucket. What we do with all the rest of the hashing algorithms is we find the next open bucket, and the way we find the next open bucket is where the algorithm comes in. And so for double hashing, we actually have two hash functions, and we take the first one, and then we add some multiplier times the second hash. And if there continues to be collisions, then the I is incremented, and that's how we, and the idea is that we want to have these hash functions, so when there are collisions, there aren't very many of them. They're minimal, and when keys are mapped into buckets, with the fewest number of collisions, you're able to fill the most number of buckets. So that just depends on a lot of things, and it's a bunch of things that affect random numbers. And so if you're serious about this, probably what you do is you would start with one hashing function, and then you would try it out, and you would count collisions, and you would try it out on a bunch of data, like a whole bunch of data, and you may change your hash function based on the data through experimentation. So with this one, there's two hash functions, and the index is computed this way. And so I might bring up a whiteboard here. Which I will use if I need to. Let's see if I can move them. All right. Anyway, so this is iterating through sequential I's is called probing. So here we have where the first hash function is whatever the key is, mod 10. We see that there are there's actually 13 buckets. There's 13 buckets. See, 0 through 12 there's 13 buckets. And the first hash function is we just take the key mod 10, and then the second hash function is we take 11 minus the key mod 11. Okay, so we do the key mod 11 first, and then we subtract that from 11. And so that's what hash 1 and hash 2 are. And so the probing sequence is this, where we take whatever the first one is, and we add whatever the second one is times I. And each time we get a collision, we increment I. And I think we start I out at 0. So the first time, okay, so let's try this, okay. So we're going to start from the beginning, and we're going to insert these items. So we insert well, anyway, they get inserted that way, I guess. And then the next thing we're going to do is we're going to insert 55. So I guess, okay, I see this. Okay, so we're going to start with 72, 60, 45, 18, and 39. And so the first time you do it, you always have I equal to 0. So the first time we try to map it into a bucket, we are only using this hash function. And this hash function is easy. It's key mod 10, which means it's just the lowest order digit. So 72 is going to go into 2, obviously. 60 is going to go into 0, obviously. 45 is going to go into 5. 8 is going to go in. 18 is going to go into 8, and 39 is going to go into 9. That takes care of all of these. And then we're going to add a 55. Well, we have a problem with 55 because there's already something in 5. If we just take the first hash function, there's already something in 5 that's 45. So then we have to do I equals 1, because I equals 0 didn't work. I equals 0 just mapped us into here. So if we take I equals 1, then we're going to just add, because this is 1, we're just going to add what the result of the second hash function is. The second hash function is this is going to be 5, because 55 mod 10 is 5, plus 1 times 11 minus 55 mod 11, whatever that is, and then we have to take it mod 13, because that's how many buckets there are. So once we have something bigger than 13, bigger than 12, then we have to take and mod the size of it, and this is likely. Well, I don't know if it is or not. Let's see, what's 11 minus 55 mod 11 is 0. Because 55, because 11 times 5 is 55, so 55 mod 11 is 0, and 11 minus 0. Oh, it's 10 plus. Okay, got it. So it's 5 plus 11 minus 0 is 11. So that's 5 plus 11 is 4. Well, anyway, when you do the math, you have to take the mod 13, because this ends up being bigger than 13. I guess it's going to be 60, because when you take the mod 13, you end up with 3. So with the first probe, with the first iteration, or the second iteration, actually, we end up with 3. Well, is 3 taken? No, 3 is not taken, so the 55 goes in there. Okay, and then the third one we're going to try is 23. 23 is taken, with the 55. So then 23 is 3 is taken, 0 is taken, but 10 is not taken, so it ends up going in 10. So you see this calculation is the same each time, because that's just the second key. This calculation is the same each time, because that's just the first hash key function. What changes with each iteration is this this thing this multiplier of the second hash function, which is what we're talking about here. This multiplier of the second hash function. So anyway, that's how this double hashing works. So you can probably go through here and make sure you know how to do the calculations and everything. This is okay. So this is for searching and removing. And again, we have to do this empty after removal and empty since start, because if something is empty after a removal, then it's like then you aren't done probing. You have to continue probing, because you find something. Well, anyway, you have to keep track of whether a bucket is empty, has always been empty, or it's empty because something was there and then it was removed. Because if it's empty because something was there, then when you are probing, and something is mapped into that empty after removal bucket, you know, just because you haven't found it and it's empty, that doesn't mean it's still not in the hash table, so you have to continue. Whereas if you're searching for something and you're probing and you end up coming across an empty since start bucket, well then you know it's not there. Because if it were there, that's where it would be. All right, so that's just a review of what you should remember from the previous sections of this chapter. All right, so anyway, this probably reinforces understanding that. So let's try to do this this challenge activity. Okay, so before we start, we have there are two things in. Okay, so the hashing function is, okay, so there's 11 buckets, and the first hash function is taking the key mod 11. Okay, so that's just gonna map into one of these, and then the second hash function is 5 minus the key mod 5. So first we take the key mod 5, and then we subtract that from 5, and then we go through this iteration thing. All right, so let's and I have my trusty whiteboard over here to use if I need. All right, so and I haven't pressed start yet, but what we're doing here is the hash table uses double probe hash functions. This is it. This table size is 11. Hash insert 55 inserts 55 into item. Oh, it's not. Okay, so it's well, let's just start it up then. So 55, it inserts 55 into 55 mod 11 is 0, because 5 times 11 is 55, and so there's, if you take 55 and divide it by 11, you get 5 with no remainder. So that's the remainder is what the mod is. So that would go into bucket 0, because we're only using this hash function, and this factor, and that was 0. So I would say the answer is 0. Where would 81 go? 81 would go in, what's 81 mod 11? Well, what's 81 divided by 11 is like 7 with a remainder of 4, because 77 plus 4 is 8. So that maps into 4. And 4, 4's got something there. All right, I gotta start using the whiteboard, I guess. Oh, these are tough ones. So I'm gonna go. Oops. So for 55, 55 mod 11 equals 0. 81 mod 11 equals 4. And 4, there's already something in 4, so now we want to do what the iteration of adding hash 2 to 4, and so hash 2 is 5. Use this color. Yeah, that's okay. 5 minus. We're talking about 81 mod 5. Well, 81 mod 5 is 1 because 80 divided by 5 is 0. Mod, so it's 1 equals 1. And 5 minus 1 equals 5 minus 1 equals 4, right? And so this is the first hash function for 81 because we're trying to insert 81. And then this is the second hash function here. So 4. So and you take hash 1 plus, it's hash 1 plus, right? Yes, it's hash 1 plus. So so 4 plus 4 equals 8. 4 plus 4 equals 8. So I'm going to say that this is 8. Wait a minute, can't be 8 because there's already is my thinking right? 5 minus 1. 5 minus 1 is 4. And you add it because I is 1. So it's just 4 plus 1 times 4 is 8. And so that puts me there. I guess I can't, there's already something there. So now what do? I have to do 2. I have to do 4 plus 2 times 4. And 4 plus 2 times 4 is 12. And 12 mod 11 equals 1. Man, I don't know if this is going to be right, but let's just keep trying to see if we get this right. I'm going to make this a little bit small. Okay, so I'm going to say this is 1. And then the third one is we're trying to put 15 in there. And 15 mod 11 is 15, I guess it's 4, right? 15 mod 11 is 4, so that puts me right there. And so now I need to figure out what how can I? Let me just move it like this. Okay, so do this. So the key is, does this work? Oh, yeah. 5 minus the key is 15 mod 5. Well, 15 mod 5 is 0, so 5 minus 0 is 5. This equals 5. And so that's what the hash 2 is. So when hash 2 is okay, and I also need to make sure I have so we're trying to put in 15. 15 mod 11 equals 4. So the hash 1 is 4. Okay, so 4 plus 5 equals 9. Right? Is there something at 9? No, there's not. So I'm going to say this is 9. And I'm not going to bother to check my work because it's probably wrong anyway. And let's just see what the answer is. Oh, all right. Looks like that was the answer. Very good. I'm so smart. I'm so lucky. All right, let's try the next one. Okay, got it. All right. So the hash, it's the same first hash function. The second one is 5 minus. It looks like it's the same second hash function also. Table size is 11. 34, 50, 85, and 32 are already in there. What is the specific sequence of buckets probed when we're trying to remove 28? Okay, so the first one we're going to look at is what's 28 mod 11? It's 33 is be 0, so 32 would be 10, 31 would be 9. No. Let me think about it. 30. I'm doing 28. 28 mod 11 is 22, 23, 24, 25, 26, 27, 28. Okay, so it's 6. That doesn't make, that's not right, is it? Yeah, I guess it is right. 28, it's 28. Yeah. Move this. Oh, isn't that how I do this? Oh. Okay. How do I do this? Oh, okay. 28. 28 divided by 22, no, divided by 11. Sorry, it's taking some. Divided by 11 equals 2 with the remainder of 22 is 6. Okay, so this is what 28 mod 11 is. 28 mod 11 is 6. So hash 1 is 6. Now, the first place it's going to look at is 6. Okay, and 6 is already is 6 is something there, and it's not 28, so it's going to look at 6 and commas between the values. And so the next time it's going to look at, let's see what hash 2 is. Hash 2 equals 5 minus 28 mod 5. 28 mod 5 is going to be 3, and 5 minus 3, this equals 3. 5 minus 3 equals 2. So the hash 2 is 2. When I equals 1, the hash 2 is 2, or that's 6 plus 2. So 6 plus 2 equals 8. And so it's going to look at 8. Oh, there's something there. Okay, it's making progress here. So so next we look at 6 plus 2 times 2, right? Which is 10. 2 times 2 is 4, plus 6 is 10. So then it's going to look at 10. Boom, there's something there already. Uh-oh. Wow, this is going to take a long time. Okay, and then, so that's 2 times 2. So next it's going to be 6 plus 3 times 2. And that is 6 plus 6 is 12. But we got to do mod 11 because it's more than 11. And that's going to equal 1. 12 mod 11 is 1. And so then it's going to go look at the 34. Look at, oh gosh. They're just, this is a wild goose chase. All right, so 3 times 2 doesn't work. So let's try 6 plus 4 times 2. So 6 plus 8 is 14, and 14 mod 11 equals 3. So now it's going to look at 3. And I'm not going to bother checking my work because it's right. All right, there we go. See that? There's the 0, the 1, the 2, the 3, the 4, and it's 5 minus 28 mod 5. All right, we're on a roll. Let's do number 3. Okay, so now with same hash 1, same hash 2, same table size, and can I do something like clear canvas? Yes. All right, so we have a hash. So now we're gonna look for what is the specific sequence of buckets probed by searching for 99. Okay, so hash 1 is going to be 99 mod 11, which is going to be equal to 0, because 9 times 11 is 99, so it goes in evenly. So that's 0. And so the first one it's going to look at is 0. And there's something there, of course. Wouldn't be that easy. Oh, look, we've got an empty after removal. Oh, this is going to complicate things, isn't it? Okay, now hash 2, something there, so we got to calculate hash 2. Hash 2 is hash 2 equals 5 minus 99 mod 5, which is equal to 4. 99 mod 5 is 4. And so 5 minus 4 equals 1. This is equal to 1. Okay. So this is kind of, so we're going to start. So each iteration, we're just adding 1 to it, it looks like, because it's just 1. And we start at 0. Okay, so we're going to start with 0, and then we're going to add 1 to it. It's going to be 1, then it's going to be 2, then it's going to be 3. And so first it's going to look at 0, and it's not going to find it. Then it's going to go to 0 plus 1. 0 plus 1 times 1 equals 1. And after that, it's going to be 0 plus 2 times 1 equals 2. And then it's going to be 0 plus 3 times 1 equals 3. So in other words, it's going to look at 0, then it's going to look at 1, then it's going to look at 2, then it's going to look at 3. And if number 1 were empty since start, then it would stop after 1. It would say, sorry, we didn't find it. But even though it's empty, because it's empty after removal, then that means there could have been something there when 99 was inserted. And in fact, that must have been the case, because look, 99 is all the way down here. So I'm going to say this is the answer. Yeah, there we go. Empty after removal, so the search continues. And now I'll do the last one. Okay, so same hash 1, same hash 2, same table size, and this time we're going to do how many buckets does hash trying to search for 41. We're searching for 41. And so let's just so hash 1 is going to be 41 mod 11 equals what's 3 minus this well, it's going to be 41 divided by 11 is 33. So it's going to be 3 with a remainder of 9. Is that what it is? 33 plus 9 is, no, 8. Must be 8. 33 plus 8 is 41. So I think that's 8. So 8 is the answer. 8 is the answer to the first hash. And this, okay, so the first thing it's going to look at is 8. Oh, there's something there, wouldn't you know it? So that's one bucket. And then we're searching for 41. So hash 2 is hash equals 5 minus 41 mod 5. 41 mod 5 is 1, so 5 minus 1 equals 4. Okay, so the first time it's going to be 8 plus 4. And the next time, and so 8 plus 4 is 12. 12 equals 12. 12 mod 11 is equal to 1. 12 mod 11 equals 1. And it's searching for 41. 1 is empty after removal, so it's going to continue because it could be it's even though it's not okay. So and then it's going to go 8 plus 2 times 4, which is 8. 2 times 4 is 8, so 8 plus 8 is 16. 16 mod 11 is 5. So then the next one it's going to look for is 5, and lo and behold, it finds 5. So it takes 1, 2, 3, 4. 1, 2, 3, 4. First it looks at 8, then it looks at hash 2. This is just hash 2. This is not something. Let's put a box around this. So this is the first one. This is the first one, and then this would be the second one. And this would be the third one. So it looks at 3 of them. How many buckets does hash insert vals item 41 for inserting? How many buckets does it probe? It's gonna first probe 8. There's something there already. Then it's gonna probe 2. Oh no. Then it's gonna probe. Look at 1, and 1 is empty, and so it can insert 41 at 1. So we can put so it's only gonna do 2, right? Because first it's gonna try to put it at 8, and then it's gonna try to put it at 1. That's 2 probes. Let's see if this is right. Hey, okay. All right. So that's all of them, and so whatever versions you get, you should be able to do that. Okay, so so do you have any? So are there any other challenges that you were stuck on?
No, actually, if I get it done, that'll be 100% for everything.
All of the challenges, okay. All right. Well, why don't I end this video and post up these 2 videos, and maybe we'll see you in future videos. But if you're all done, then that's great. So, and I will continue to do challenges and labs that aren't done yet for the rest of the class.
Great. Don't mind if I might, you still might see me being a fly on the wall.
All right.
Thank you.
Very good. Okay.
Sir.
Thanks, everybody. Take care.